The main thing that we found in this study was that there is a connection between heat wave intensity here in California and convection or thunderstorms occurring in two regions of the tropics. One of the regions is in the eastern Indian Ocean along the equator, and the other one is near Central America, eastern Pacific Ocean. It's been well known since the 1970s that a prominent way in which the weather varies in the tropics is through a moving pattern of thunderstorm that they move across from the Indian Ocean, across the Indian Ocean, Indonesia, into the Pacific, and all the way across to the Americas. And this was discovered by Roel Madden and Paul Julian, and they wrote a paper on it in 1972. We now call it the Madden-Julian oscillation. So it's something that has an approximate time period on the order of a month to 2 months. Pattern is well known to be associated with other things, like rainfall in certain parts of the country is stronger. In the wintertime there's some things that seem to be related to it, but in summer and heat waves over California that had not been previously noticed. In my research, we're looking at extreme weather of various types. So some of them are temperature extremes, like really intense cold waves, as well as heat waves. We're also looking at extreme precipitation. So the thing that I do that's innovative is we look for the large weather patterns associated with these extremes. And in the process of doing that, we expand the area we're looking at to not just include California, but much further to the west and north and south of the region. And as when we did that, we started to notice that there might be a hint of something connected with the Southeast Asia region. So that motivated us to have this later study where we focused on just that region, but we already knew about the MJO. So that told us, just look in the whole tropical belt there. And the MJO, it's well established. You can go online, you can find out what phase it is in and so forth. And you can track it back for a month, see where it's been. So it's easy to get that kind of information. And when we looked at that, we found that on the order of about 1 to 2 weeks prior to the onset of the strongest heat waves here, we had unusually strong MJO activity, but only in these two regions. So, it's coming across over a long tropical belt, but only in this area of the eastern Indian Ocean and on the sort of the far end of it near the west coast of the Central America. Imagine looking at a river and a large boulder in the river. So the water flowing along comes up the boulder and then flows over it, and what happens on the other side? Well, it kind of dips down, right? And then comes back up. And it may even have another crest and trough after that. So if you think of the rising part there as being those thunderstorms that are unusually intense in the eastern Indian Ocean, and then the sinking being areas, let's say east of the Philippine Islands, even into the South China Sea, into the Central Pacific, that area is where you have sinking, then that can also lead to sinking here, either through another crest and wave before that, or even just extending that sinking motion past that point. So in that sense, it can reinforce the pattern locally here of sinking. Yeah, we didn't identify a direct relationship between that. We didn't really look for it either. One reason was we're looking at the 28 hottest heat waves. There's not a lot of good statistics there to calculate, let's say, a regression curve or something like that, where we could get some decent statistics on saying, okay, more intense there was also a stronger heat wave. There's another reason as well, and that is, think of this as something that, like I said, could either reinforce or oppose a larger scale pattern. So you really need that larger scale pattern. And that's going to, and it's in our latitudes, not in the tropics. And that pattern is something that it is strongly connected to the intensity of the heat waves. When that pattern is stronger, the heat waves are stronger, and that's something we did prove. So what this tropical connection is doing is either adding a little to that or subtracting a little from that. First is you'd want to look for the pattern in the middle latitudes, what we call the middle latitudes, which let's say goes from 30 degrees north to 60 or 70 degrees north. And if there's a specific pattern out there, and especially in our region, the elements you need locally are as follows. You might think you need the hotter air over the Central Valley, but actually you need it over the coast or even just off the coast. Not at the surface, because you've got the cold water anyways, but let's say starting about 5,000 feet above, and you have this hot air there. What that does, if you have the hotter air there instead of over the Central Valley, then that hotter air will be less dense, and so the pressure, which is the weight of all the air above a point, will be less off the coast. And you'll have, the other thing you need is higher pressure over the Rocky Mountain region. And so that creates a pressure gradient from high towards the low at the shore. So that drives an offshore flow that helps oppose a cooling sea breeze. Because, you know, if it heated up the Central Valley, you know, it's just going to want to send a sea breeze roaring in, cool everything down, no heat wave. So there's a specific pattern with that. It's a ridge trough ridge pattern with a ridge right over us and slightly to the west of us. Also, the other thing about that sinking, coming from the Rocky Mountain area, that air has to sink. And so when it sinks, it warms up because it's compressed. And also, what you do is you create an inversion, which we always have in the summer anyways, because there's always some sinking, but it just presses it down even closer to the surface. So it makes the top of that inversion hotter, but also you have a small volume of air, so when the sun comes up, it can heat that up in a hurry. And that's why, you know, we can have the overnight low in the 70s, but then we're bouncing up to 105 or more during the day. So you need these elements to be present. So you would look for that in your forecast. And say, aha, here's this sort of combination that's starting to form, so we know there's going to be heat wave. Now I would go look in the tropics, and we have convenient indices that make this easy to do. Has the MJO index been greater than a certain number in either of these two areas, and over the previous, let's say, 3 to 16 days? Greater than 1 in magnitude. So that's usually a threshold that's conveniently drawn on the NOAA weather product that you can look at. If there's this tropical convection connection, then you could look at your model and say, okay, how well is it handling that tropical convection? If it's a model that's not handling that very well, then maybe you want to look at something like these online MJO indices and adjust your forecast slightly up or down depending upon what's happening there in the 2 weeks before. More than likely the models are handling that fairly well, but different models handle this differently. Another way would be if you had a weather enthusiast, you know, watching your show, or a forecaster like yourself, and there, you know, you might consult some of these online resources and adjust your forecast up or down a degree, that sort of thing. Well, to complete the research, that's kind of a long story. So we completed 90% of it fairly quickly, but then my collaborator, Young, she was able to find a job in her home country of South Korea, and so she left for that, and we didn't finish the last 10% for 3 years. So finally I had people bugging me about it. You know, I saw you give a talk on that. When are you going to write that up? So finally part of my job, since I'm in the College of Agriculture, is I'm supposed to do things related to agriculture or socially applicable things, so it could be weather forecasting, that kind of thing as well. So I've done some literature research in the topics of what extreme weather affects which crops and at what points in those crop developments. So heat waves, they impact a lot of crops, and unfortunately one of the best ways to mitigate for heat waves is to put on more water, but everyone wants more water that's not there.